Thank you, everyone. I flew up here from sunny Florida, and it wasn't for the weather. It was for our topic today of science. So, what is science? Do you think of science as fuming beakers and lab coats and a guy in goggles who looks like he's been awake for too many days? Well, you're not alone. So let's take a look at the actual definition of science. I have it written right here. So science is the intellectual and practical activity that involves the systematic study of the structure and behavior of the physical and natural world through observation and experiment. Glad we cleared that up. So let's bring it down to earth. What is science? Science is in everything. It's in not just the periodic table and beakers, it's in the lipstick that you're wearing, it's in your swimming pool, it's in the drink you ordered last night, and yes, it's inside you. So scientific principles affect our daily lives in many, many ways. The car you drive, for example, was designed by engineers who are experts at getting you from point A to point B. The soap you used this morning was designed by chemists who specially formulated it for your sensitive skin. So what I'm here to do is bring us together under our principle where we're going to step back and take a look at the world through a new lens and see the many ways that science affects us every day. So I'd like to start out, and I'm thrilled to give you my talk, which is the universe in you. So as Leah said, I am a host on the Science Channel. So what we've done is we've put together a little clip to introduce the topic. And it's based on the question, where is our place in the universe?
We are a nation of seekers, makers, doers, conceived by rebels and born of fearless possibility. Unreal. We are the nation of science. We are driven by facts, inspired by what ifs.
Oh my God!
And connected by a universe of questions. While others stop to think, we never stop thinking. When others say, why bother?
Lift off.
We say, why not? We are a movement of millions, and nothing can hold us back.
We have more questions than answers.
This is where imagination evolves, where genius comes to play, where smart tells its story. So stand up and question everything.
I love that theme, question everything. If you have kids, you can relate. So, we often think of ourselves as being in the universe, but the beauty of being a human being is that we recognize that the universe is in us. The earth is in us, the stars are in us, and we're even connected to the birth of the universe. For example, it's commonly known that the salinity of human blood matches that of the earth's oceans. But it's not as commonly known is that if you look at the abundances of the elements in the universe, the most abundant being hydrogen, then helium, then carbon and oxygen, and you compare that to the abundances of the elements that appear in the human body, they match almost exactly. The only difference, for example, is helium, which does not react. And also, the universe is tied to our everyday existence. How exactly is that? Well, let's look at another quick clip.
TV static holds a clue. 1% of the static on this screen comes from light from the Big Bang. In 1964, astronomers Arno Penzias and Robert Wilson were listening to radio signals from space. But in every direction, they were picking up a background hum. Puzzled by the hum, they suspected they knew the culprit and swept the entire receiver free of pigeon droppings. But to no avail.
If anything, the background got even greater. And according to legend, when they gave a talk at Princeton, one physicist raised his hand and says, either you are listening to the effects of bird dropping or the creation of the universe.
I love studying the origin and evolution of the universe. And when I do, I can't help but notice the trend. So let's take a little trip from the beginning of the universe until now. And we see that there is sort of a trend. Our universe did not have to evolve. It was born in this state of very low entropy, and it has been evolving through entropy increasing, but also through the minimization of the forces, right? So we have a universe that's born with almost equal amounts of matter and antimatter. The matter and antimatter annihilate. The small residual of matter is what forms what we call the universe today, the matter in the universe. Then the universe goes neutral under what we call the strong force, the nuclei form. Then the universe, about 400,000 years later, goes neutral under the electromagnetic force in an event that we call recombination, and that's when that light was created. That's when it was set free. And then, since that time, the universe has been going neutral under gravity, right? So the stars are formed, and as the universe has been expanding, it's been cooling, and as you cool matter, simple constituents come together to form more complex entities. So eventually stars formed, planets formed, life evolved. Life evolved on Earth. And what do we know about life? Life operates under the simple rule of survival of the fittest. So if I were to look at life in our universe, and I was to ask myself, well, what kind of life does our universe select for, right? The better you are able to fit into your environment, then the better you are able to survive. So when I look at what's happening in our universe, I see that stars are dying. Here we have a supernova, and it's next to this galaxy. So galaxies consist of over 100 billion stars on average, and that single exploding star is brighter than that entire galaxy of 100 billion stars. And if you add up the entire luminosity of a supernova, some of the radiation you can't see, like neutrinos, for example, you'll find that a single supernova is brighter than the entire non-exploding universe put together. We also find stars that are dying without exploding, but yet throwing off their outer atmosphere. This is what the sun is going to do one day, and they form these planetary nebulae. We see one here, we see another one right here. They're very beautiful. And then we look at the bodies in our solar system. What do we see? If they have a solid surface, they're cratered. And what we know about the Earth is that it has a history of extinction events. So if you are a species in this universe, on this planet, the day you come into existence, the clock is ticking, right? Either you're going to find a way to get off your planet or you're going to become extinct. So the universe is an ecosystem, and it selects for species that are able to leave their planet and occupy others and hedge your bets, right? If you're adaptable, then you can survive into infinity. And what is going to get us there? It's science. And so there's a strange phenomenon that's been happening, and I like to tell this story from history. Here's a picture of Galileo. So Galileo heard about this new invention that we call the telescope. And so he built himself one. And in fact, he built the world's best telescope at the time. And what did he do? He turned it to the heavens, and he looked at the moon. And now at this time, people thought that the moon was made of something very different from the earth. But what did he see? He saw that the moon had mountains and what he thought were seas. And he said to himself, oh my God, the moon looks a lot like Earth. And then he turned his telescope to the planets, and he looked at Jupiter. And at this time, people believed that objects could only orbit the Earth because it's at the center of the universe. And what did he see? He saw these 4 little dots that he thought were stars that appeared to be orbiting Jupiter. But even more startling, he saw and he noticed that Jupiter, through his telescope, looked a lot like the moon looks to the naked eye. And he put it together. And he said, here it is, the moon looking like the Earth, and Jupiter looking like the moon. So could it be that Jupiter is another Earth? Or even worse, maybe the Earth is just another planet. And so what Galileo did is he called together the civil and religious leaders. And he said, hey, look, what we think is true is not true. And what we like to say in science in terms of advancement, what stops you is not what you don't know, it's what you know that ain't so, right? And so Galileo said, it ain't so. So he called these civil leaders together, and he had the very first telescopic star party. And he had these people look one at a time through his telescope. And he said, look at the moon. Do you see the mountains? And what did they do? They looked one at a time and said, I don't see any mountains. And he said, look at Jupiter. And you see these little dots, these little stars that appear to orbit it. Don't you see them in a line around Jupiter? And they looked one at a time and they said, I don't see any dots or stars. And believe it or not, that kept occurring until the invention of photographic film, where now we can set the image down on the table, and if you say you don't see what's on the image, obviously you're insane, right? But today, we have the same type of phenomenon that's going on. we have scientists, the very first one who thought that they had a good age on the earth and that it was much older than expected, was looking at Niagara Falls, and based on the rate at which the falls were retreating and the sedimentary layers under the falls, this person came up with an idea that the earth was at least 30,000 years old. And someone said, you don't see that. And then we come to understand that, hey, maybe life forms are evolving. And people said, nope, scientists, you don't see that. And then we discovered the evolution of the universe. The earth is billions of years old. The universe began in this very hot, dense state that we call the Big Bang. And people said, no, you don't see that. And now we actually have people who study the evolution of the Earth's atmosphere and have come to the conclusion, they dedicate their lives to this scientific endeavor, that in fact the Earth is warming. And people say, nope, you don't see that. And I think that this is a dangerous trend for us, because we have the physical world and we have the natural world. And if you look at the trends among humanity around the world, one of the biggest obstacles to this cooperation with this scientific process is certain members of our faith community. And if you look at the trends, what you see is that the faith communities are a very strong function of geography, right? If you go to Saudi Arabia, it's very different than if you're in China, and it's very different than if you're in Alabama, for example. So what we have now is a circumstance where our very survival, we are an awakening species. We've come to understand that we have to leave this planet and we need to start preparing now, and that is our human destiny if we're going to continue to live on and be humans. And we can have whatever spiritual or faith tradition we want, but we must all live in the same physical world, the same natural world. So if you look around the world, E equals MC squared everywhere, right? Force equals mass times acceleration everywhere. So I have a challenge for you. My challenge is that for you to go out and help us fulfill our purpose as human beings. Our job is to understand this world that we live in at its most fundamental, pass on that knowledge to the next generation where they can build on it, and for our species to live forever into the future. So thank you very much. That's my talk.